Okay, so here is our first example of graphing a tangent graph. And so let's start at the top. Okay, so we know that the physique is going to be this guy right here. Okay, and so for our physique, we are looking at 1/2, which means is that it is going to be a wider function, just like the videos have shown before. Okay, it's in between these guys right here, in between 0 and 1, and so it's going to be wide. Now, the period in this case, and I want you to pay close attention, is going to be, this is where B is, right here, and it is going to be calculated by, instead of 2 pi, since the original period of tangent is pi, we would get pi divided by that number 1, which is just going to give us pi. So now, this is where it's really important to, why I showed you guys where to start the graph, okay? You always want to start symmetrically around the y-axis. And so it's going to end up being pretty straightforward in this one because we didn't, I rigged it so it doesn't adjust the period whatsoever. But it's going to be in between here, positive pi over 2 and a negative pi over 2. Okay, so that's where one period of the graph is going to exist before we shift it around. And what I do is that I usually just put a little place marker right in the middle of what the graph is going to, that's where the graph is going to hit the x-axis. And so until I get to the next part, shifting it around either horizontally or vertically, that's what, then I'm going to finish out the graph afterwards. So in this case, I have, for the phase shift, I have a negative. So I know the negative, it is going to be going to the right, okay? And I have, again, it's just going to be pi divided by 3 all over 1. So it's going to be like C over B. That part is the same. And so we would have, shifting the graph, pi over 3 to the right. So now, that basically means is that if I'm shifting everything pi over 3 to the right, all of these points are going to skip on over. So let's start doing that. So the greatest hits are going to be the x-axis, okay, and then both asymptotes. So you can see that that's 2 spaces to the right, and so this is going to jump 2 spaces to the right, and this is going to jump 2 spaces to the right, and this is going to set up the graph from here. So I'm going to start this guy. Okay, that's the moved asymptote. This is the moved x-intercept, and now we have the asymptote moved on over. Okay, so I'm going to get rid of the other parts of the graph, or the stuff that we shifted from, so we can see a little bit easier. Okay, so now things kind of look like this. And so what I like to do is, especially if we're all done with it, we don't have anything going on in a vertical direction, which is going to be that value that's out here. We don't need to worry about that. So I like to continue the pattern, and it looks like the way that I pattern things off, I try and count from any one of the either the x-intercept or the asymptote. So this is going to be 1, 2, 3. So it looks like there's going to be 3 spaces, and changing those, like interchanging from an x-intercept to an asymptote. So I go 1, 2, 3 over here, and 1, 2, and there's going to be like an asymptote somewhere over here. And going back 1, 2, 3, there's going to be an x-intercept and all that other good stuff from there, and then an asymptote. Now, here is what we're going to go ahead and kind of put some pieces together first before we start knocking these out, like the x and y intercepts, and then we'll start graphing everything to make it very true to its nature, rather than sketching it and then having to go back and fix things. Okay, so finding the x-intercepts, this is how we go. Okay, so we know that this guy right here, let's see if we can find the distance between these two right here. And we have the first x-intercept, which is going to be pi over 3. So I'd go pi over 3, oops, plus, and it looks like I'm going pi increments to the next x-intercept. So you can verify that by just taking the difference between 5 pi over 3, which is this guy, and then minus pi over 3, okay, which is just going to give you 3 pi over 3, which is just pi, okay? So that is the distance between every x-intercept right here is going to be pi. So we start off with pi over 3 plus pi n, where n is an integer, okay, and then comma 0, and that's going to give us all the x-intercepts, okay? And so that's we learned that skill in sine and cosine, and we're also going to have to apply it to the domain in this in a moment. So, but first let's find this this y-intercept. Okay, so finding the y-intercept, we know that we got to plug 0 in for x. And so if I'm going f of 0 here, finding this by hand, I get 1/2 tangent, and this x is 0, so I got a negative pi over 3, okay? So the tangent of a negative pi over 3, to review, we have this guy going on here, and we went a negative pi over 3 in this direction, which looks like we're going to have pi over 3 as a reference angle. We are in cosine's quadrant, so we know that the answer is going to be negative, okay? So it looks like the tangent of pi over 3 is going to be root, oops, actually not going to be root, it's going to be, I'm sorry, it is going to be root, square root of 3, but it's going to be negative, okay? And then we have to multiply it by this half right here. So I'm going to get this times a half, and that's going to give me approximately a negative, let's see, we're on, so approximately a negative 0.87, okay? And so it looks like I'm going to have 0, negative 0.87, where it looks pretty good. Looks like the way that the graph is going to go here. So I'm going to put that guy right there. And let's go ahead and get the domain. The domain is going to be broken in a bunch of different spots. And so we look, and we got breaks in the domain right here and right here. But what we want to do is that we want to take the first positive break in the domain where an asymptote is at. So it's going to be all real numbers, except, okay, x equals 5 pi over 6, and then the distance in between each one of these asymptotes, which we know is going to be pi, okay, the same distance in between the x-intercepts. And so, except when x equals 5 pi over 6 plus pi n, and then where n is an integer, and I ran out of space, so I'm going to leave off, well, I hate doing that, where n is an integer, okay? Oops. And then finally, the range, which I'm going to write down below here, is going to be a negative infinity to a positive infinity, and will always be so in case, or unless we have a word problem, okay? So from here, we're just going to sketch, okay, using the fact that we got the asymptote set up in the correct spots. We know it's going to be a little bit wider. We have some intercepts to trace around. And so the way that I would do it is that we kind of continue on with this pattern here, doing the best that we can, going on up and trying to have some of the breakpoints be the same so it looks legit. I might go backwards on this one just because it goes off the graph, and etc. Okay, so that would be the graph of that tangent function, and yeah, that's how we're going to do that out moving forward. And so that's how you do that one, and I'll see you on the next example.